Good afternoon, dear participants of the conference. My name is Siyanko, and I'm a graduate student of the Kozakevych National University. I want to present you an article on the topic Research of Modular Multilevel Converter with Phase-Shifted Pulse Width Modulation. The introduction of the adjustable frequency electric drive for low-voltage AC motors over the last decade has proven to be an effective method of improving energy efficiency in industry and utilities. However, high-power electric drives using medium-voltage motors also have significant energy-saving potential. There is no single approach to the construction of power converters of such systems. Therefore, the development of means of converting electricity in systems with a medium level of rated voltage is an important area. Having analyzed the possible options for constructing circuits, more promising now is the use of circuits based on voltage source inverters. The use of multilevel inverters also to reduce the total harmonic distortion ratio, which reduces the size of the filters on the AC side. Multilevel converters based on the circuit with cascades H bridges, circuits with plain capacitors with diode clamped converters, and modular multilevel converters are certainly being mass produced, and we can see this scheme on slide. In addition, scientists are constantly developing new schemes that are certain combinations of exciting options. The main disadvantages of the circuits with cascade edge bridges is the need to use a phase shift transformer to obtain several galvanically isolated DC sources. The disadvantages of circuits with flying capacitors and clamped diodes are the difficulty of balancing the voltage on the capacitors dividers. The scheme of a modular multilevel converter does not require a complex transformer, and therefore its use is more appropriate for reasons of economy and reliability. The most popular is the scheme of half-bridge modules. It contains two switches operating in inverse mode and provides two levels of output voltage. Zero voltage and voltage equal to the voltage of the capacitor you see. This scheme is able to provide a low level of energy loss and high reliability. The use of more complex schemes of converter modules is explained by the need and the expediency to have more levels of output voltage, which reduces the total number of semiconductors elements used. The overall dimension on the module multilevel converter. As such modules, the bridge variant, this scheme allows the obtain a bipolar output voltage, which is used both in terms of increasing the flexibility of voltage balancing on capacitors, in terms of possibility of reducing the magnitude of the emergency current. The use of circuits with a fixed zero point and with flying capacitors allows to significantly expand the number of switching states and therefore requires more complex control methods with the ability to maintain voltage balance on capacitors. Consider the equivalent scheme on one face of multilevel inverter. The formulas for determining the current and voltage in the converter are presented on the slide. The principle of pulse width modulation with phase shift of the carrier signals is presented on this slide. To obtain the switching signals of the switches of the converter modules containing and modules on the arm, the phase shifted trigonal carrier signals are generated to control the upper half of the circuits and the same signals to control the switches of lower half of the circuit. The frequency of the triangular signal carriers is selected dependent on the required switching frequency of the semiconductor elements. Subsequently, the sinusoidal reference signal of each phase is compared with a number of triangular carrier signals, and the corresponding control signals of the circuit switches are obtained. To improve the coefficient of total harmonic distortion between the triangular carrying signal, a phase shift of 2p dou n is set. Thus, it is expected to investigate the influence of the magnitude of this shift on the performance of a modular multilevel converter. A mathematical model in Matlab Simulink environment has been developed to study the influence of the carrier shift angle on the operation of a modular multilevel converter. The parameters of the simulated converter are given in this table. On the slide I present the similar result of modular multilevel inverter with a shift of carrier signals by 2p0 The shape of the output voltage has a clearly visible number of levels, which corresponds to the number of modules in each arm of the converter. Circulating current has a frequency which corresponds to the frequency of the output voltage of the converter, and it although the fundamental harmonic which corresponds to the frequency on the output voltage is visible not noticeable. However, the arm's value of the circulating current includes almost twice to 11.8 amperes, which leads to the increase in loss the converter. Another significant disadvantage of the method of modular is the loss of the ability to balance the voltage on the capacitors of the modules. The positive effect of using such a system is reducing the total harmonic distortion to 21.71%. On this slide, we can see results of modular multilevel inverter, which reducing the values of the shift of the carrier signals to the level of 50% from the previous case. The graph of the output voltage visually shows even greater sinusoidality than in previous case. The presence of individual discrete voltage levels is almost invisible. The nature of pulsation of the calculating current corresponded to the previous case, but the current values increased significantly to the level of 19.52 amperes. Let's analyze the operation of a modular multilevel inverter using pulse width modulation with n-phase carrier signals here in the absence of phase shifts between them. The result of modeling we can see on the slide. The output voltage shows a significant decrease in output voltage levels, which is a negative phenomenon, because in this case it is necessary to use more cumbersome passive output filters to bring the output voltage in line with current standards. The current value of circulating current almost corresponds to the previous case and is 19.36 amperes, which leads to the need to increase the value of the inductance in the arms of the converter to reduce the level of losses due to the influence of this current. A positive characteristic of such module is the ability to balance the voltage on the capacitor of the converter modules. The average deviation of the voltage does not exceed 30 volts, which is the best result along the analyzed options. The decrease in the output voltage level leads to a significant increase in the coefficient of total harmonic distortion to the level of 50%, which is the worst result among the optionalized The conclusions are presented on the slide.